All right.
I thought I told you.
Classy.
That we won't stop.
So, welcome to the first talk for today. Our next speaker, James Shubin, he has started his own configuration management software project. He works at Red Hat, and he does a lots of fire shows, I guess. So please welcome James Shubin.
Thank you. I brought some beats to wake you up, but we're going to kill it for now because I got a lot of material to show you, and I'm going to go really fast. Who does not speak English? Just raise your hand so I know where you are. That's good. You're all awake. Or you all speak English. I'm sorry, I talk very quickly. If you're really lost or something, don't be shy. Just tell me and I'll try and repeat something. We have basically a full hour, and I'm the guy who throws fire, so you maybe want to be careful. So let me just get some stuff ready for you. All right. So you're here for this talk, right? So reactive systems monitoring, we're going to talk about that a little bit. I'm just going to get started. I'm going to be sitting down a little bit. So if you can't see me, don't worry. I'm here. You'll hear me. The slides or the stuff that I do in my terminals, that's what you're really going to want to see. So have a look over there. So I really want to talk about my software, about what is actually possible today. I don't know if I got the German right. I just want to show you a quick video of what I expected Germany to be like. You want to see this? I'm going to waste some time on this. Okay. Oop. Do you all know the video? Okay. Has everyone seen this? I found this and I thought it was really funny. This is what I'm expecting in Nuremberg. I don't know what they're saying, if you know. I think it's a beer keg, right?
Kein Bier heute.
Jetzt hat's. Warte mal, noch einen Schlag.
Hau rauf, hau rauf!
Du
musst reinhauen, du musst es reinhauen.
Put it back in or something? I don't know.
Zack, zack, zack. Klopf, klopf, klopf. Los, komm, weiter, 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 bis es drin ist.
Wait, wait, wait.
Mach, du musst es reinhauen. Mensch, Dirk! Hau doch rein. Jetzt ist es weg. Du musst ja
So, I couldn't help it. I gotta waste time really quickly. I'm really sorry, but I have to show you. I'm from Canada, not the United States, and this is actually a video from my city in Montreal. And then it's done with the videos. Basically, we had some snow and some ice, and the hill was a little steep, and this is what happened. Sorry for the VHS recording. So. I would have shown this in the pre-show, but Bern took a little bit more time than he was supposed to, so I'm going 5 minutes over to show you these videos. So this is our city bus, which you know, the drivers think they can just drive anywhere, and he is wrong. You don't have much snow in Nuremberg, right? So we're pretty good. We actually can get this much snow in Montreal, but everyone was just unexpected. Boom. Obviously, the police have come to save the day. But it's not over. That's the salt truck. Boom. Okay. So now we really have to get going. So who am I? I'm a hacker. I work on config management things. I work for this hat company. I write a technical blog called The Technical Blog of James. Who's seen my blog? Just raise your hand. If you haven't seen my blog, raise your hand anyway, so I seem really popular. Everyone? Thank you. You know about it now. I'm actually a physiologist by training, so if you want to talk about cardiology, I'm there. And I'm really into DevOps stuff, and I work on sort of DevOps tools. That's what I like to work on. Here's some background. This is Beaker kind of screaming because everything is on fire and everything is bad with the sort of state of the art. I did a lot of Puppet historically, and there are a lot of things about Puppet that I found could be improved, let's say. And so I thought about what to do, and people were like, don't reinvent the wheel. I saw this on the internet recently. Do we want to reinvent the wheel? I think so. So like, you want the like nice, awesome wheel that doesn't have as many problems as the first wheel. So I really sat down and I said to myself, is there an existing tool out there that is good enough, that does what I mean and does what I want? What do you guys think? Wake up. Okay, so let's see. This is my guy who's going to answer this question. I bring him to all my conferences. We're pretty good friends for a guy who doesn't have a name, but he's my nope guy. So I couldn't find something that had everything I wanted. And I want to prove to you that what I really wanted has some certain features, and I'm going to show you some of these things. So I have this tool called Mgmt. Got a nice logo. I have like maybe 40 stickers left, so if you really want a sticker, I'll give you some. Excuse me. It has two main parts. It has an engine and a language. And I'm going to show you a little bit of both today and try and give you a big overview of the tool. So the tool itself has three main points. So if you're all, who's familiar with config management a little bit? Who's not? Just raise your hand. Who's really shy and hates putting up their hand at conferences? Just let me know where you're sitting. Okay, good. So don't be shy. If you have really stuck, let me know. But in config management, we basically have these graphs, which I'm going to show you in a minute. And one thing that we can do is we can run in parallel, run the whole graph in parallel, which I'm going to show you. We're event-driven, which I'm going to also demo. And we work as a distributed system, which has some cool advantages. So I'm going to go through these three things to start. So here's a graph of a typical system in Puppet or something like that. The blue boxes in my diagram represent resources, so individual things, units of work to do. So install a package, create a file, start a service, and so on. Excuse me. And the red arrow, if you look at the black arrows, they actually represent the dependencies. And current tools, what they actually do is they do something called a topological sort. So they go through, they basically do this red line, 1, 2, 3, 4, 5, 6, and then 7. But if you have a parallel tool, you can actually run this graph. So you can run all on the left at the same time as everything on the right. And once you've done 1A, 2A and 2B can both be run in parallel. Does that make sense? Yes? Good, good, okay. So I'm going to show you actually a graph. I'm going to show you this graph. I'm going to run this graph, and I'm just going to make this a little bit more fun. So we've just built a new copy for you. It should be building. So on the left, I'm actually going to run this graph in Puppet. So this is a Puppet script I wrote, which is just literally, can you see that okay? Is that big enough? So that's Puppet, and I'm going to run the same code basically in Mgmt. So I'm just going to run Puppet here on the left. This is all running on my crappy laptop. I'm going to let Puppet have a chance to start. And now I'm going to run Mgmt on the right. And it's off to the races. Already going. It's already doing the first resource. The resources are just a little bit arbitrary. Puppet is still loading its facts. Oh, it just finished its facts, I think. I think any seconds it's going to start running. Come on, Puppet. You can do it. Got Puppet on the left. Mgmt with lots of debug output on the right. Oh, Puppet is running its first resource finally. Mgmt is going along. And we started later, right? Just to be clear. It's a little boring watching terminals, but you get the idea. Who's done watching terminals? You all do this, right? All right, so you're my people. And Mgmt, we asked it to shut down when it's done doing all the work. Normally it can run continuously, which I'm going to show you. So it's done, and Puppet is still going. And that's really one of the points. So because we're much faster, we're actually much faster software as well, but because we can run the graph in parallel, we can do a lot of things to make things more efficient so that things that really don't depend on each other, you're not spent wasting your time waiting for. Does that make sense? Yes? Don't be shy, yes? Okay, good. So Puppet's finally finished, so that's good. So I want to show you the event stuff, because this is kind of cool. So I'm going to go back into the terminal. I'm going to just kill this window. And I have a special little demo for you. Oops. So on the right, I've got nothing in this file. And I'm going to just run this hello. Oops. So on the left, I'm just going to run this very simple Mgmt sort of graph. And all MGMT has been asked to do is create a single file called hello, right? Very simple. I can show you the code, actually, just for fun. Hello. What is the file called? All right. Apples. So this is a very simple thing. If you're familiar with Puppet, this will probably look pretty familiar. And here's the cool thing, though. Once this is running, which it is on the left, the file is there, it has the contents we expect, but it's running continuously. So the cool thing is if I actually just remove it, you can see it comes right back. I can remove the file, and it comes right back, because MGMT is ensuring the state in real time. In fact, it's so quick, you can even remove the file and cat the file, and even before bash has a chance to run part 2, it comes right back. Okay? And just to be a little bit crazy, I can actually run watch. Do you know the watch command? So watch will just run over and over as fast as you can. Oops. Watch can run as fast as you can, and you can see as fast as I run watch, it's going to get MGMT to go and fix the file continuously. You get it? So this is just one example. I'm just going to kill this now. This is just one example of doing events per resource. We do something like this for every single resource. For files, we use iNotify to do this. For services, we use systemd events, and all sorts of different things for whatever resource. We even have a libvirt event. So we can actually declare in our code the number of libvirt machines or virtual machines that you want, and MGMT will ensure that state is correct. And I'm going to show you more about that later. So I think this is what I would call config management. But doing this per resource, I think it's another technology as well. What do you think it is? Scream it out. Anybody? Okay. Yes, we're at the monitoring conference. This is monitoring. So does that make sense to you? It's not a full monitoring solution. We're not trying to replace Isingo or any of these things like that. But just thinking about having the job as a sysadmin to put everything in production, to set up config management, to automate it. But you're not done if it's automated. You have to also set up monitoring, right? Yeah? Because you're all good sysadmins who do this, right? Yes, good, good. We're at monitoring conference, so everyone says yes. And that's really the point. So if we can actually build some of this into the resource level when you're doing your configuration management, hopefully it'll make your lives a little bit easier. All right? You're a quiet audience. Don't be shy. I won't bite you or set you on fire. So I just want to talk a little bit about topologies. So this is a sort of well-known topology where you have a whole bunch of clients that go off and connect to a server. What kind of topology is this? Scream it out. Don't be shy. What's it called? Let's call it client server. All right, so everyone knows this topology. What's the problem with this kind of topology? There's a central server. What's the problem with that? It's a single point of failure. What's another problem with this kind of topology? Scalability, right? So performance, if you have many, many clients, this can be an issue. This is a good topology. It's a very well-known topology. Lots of useful things are built this way. But I just want you to understand it. Here's a slightly different topology, where in this case you have a single thing. This is called a central orchestrator, or just an orchestrator. And the orchestrator goes off and connects to a whole bunch of machines. What's the problem with this kind of topology? What? I can't hear you so well, but so someone else. Or go ahead, loud. All right. I'll give you a hint. It's same as before, right? You still have a single point of failure. Am I right? And also, you still have some performance problems, potentially. So in MGMT, what we do is, this is actually a graph of everyone connected to everyone else. We don't do this, and what's the problem with this topology? Synchronization is actually not the problem. Scalability, so if you have a very large number of peers and everyone's connecting to everyone else, there would just be too many connections. So here's what we actually do. What we actually do is we have as many peers as you want, and everyone, a few sort of random ones that are selected with a distributed algorithm called Raft in our case, become a sort of tight cluster where they all connect to each other. And everyone else connects to any one of those. And the cool thing is if one of these central machines dies, you can automatically re-elect another one to take over. And this central core we use for doing some fancy logic stuff, use Raft to elect and make cluster-wide decisions without a single person making the decision or a single host. So that's sort of what I'm going to show you today. So you want to see a demo, or are you sick of demos? Yeah? This guy's like, yeah. OK, cool. He's excited. So I'm going to go over here. I'm going to do a kind of, I wonder if I have a, I don't have this. I'm going to run a whole bunch of machines, but I'm going to run them all locally and just pretend they're different machines on my laptop. So just to, oops. There we go. So what I'm going to do is I'm just watching these 4 files, because I'm going to have each machine put some data in this file, and that's just going to show you in real time what it looks like. And what I'm going to do is I'm going to have each machine start up. I'm going to start them up one at a time just so you can see what's happening. And each machine is actually going to create a random string, and it's going to put it into this distributed database. And everyone else is going to see what strings are in that database and pull them down. This is basically kind of like a service discovery kind of pattern. So I'm going to run the first one, and let's see what happens if we run it. So you can see the first one is the only one running at the moment, and you can see it shows that it's hostname 1, and that's the random string that it happened to generate. So it sees its own string. That's what happens when I start up a second machine. So they automatically cluster together. All you do is you point the new machine at anyone in the old cluster, and they'll do this clustering. You'll see there's a few other commands I've added here. These are just extra ports, because I'm running everything locally on localhost, so I have to pick different ports so the servers don't collide. But other than that, you just run this, and very quickly you see the first one actually wakes up and notices that it has data from both of them. So now the first one has H1 and H2's data. Okay? Does that follow a little bit? Want to see a third example? Yes? All right, you're waking up. That's good. Let's just start a third one. Start up here. It's running, and under a second, basically, it's running. So what's actually happening here? This is a very useful pattern. One of these machines, for example, could be a load balancer, and everyone else could be a web server. And you want to actually have that data, that monitoring data, if you want, about when that machine comes up. You say, hey, I'm here, here's my IP address, here's some password you need, or some other thing, and that other machine will see it, and automatically, very quickly, use that to edit the load balancer or some other pattern. This is actually kind of like similar to what you might have in a conference room. So everyone goes into a conference room, you say, hi, my name is James, and everyone else says their name as well. And that sort of pattern. And we can do this actually in milliseconds. This is very similar to what Puppet might call exported resources, except exported resources take like hours to run, or hours to exchange in a whole cluster, whereas this is under a second. Is anyone lost about this? I was told to go really hard on you guys and make it really more in-depth, so that's what Bern said. So if you're unhappy, you have to tell me. Good? Okay, don't be shy. If you've missed something, I have some of this material recorded as well, and there's some blog posts, so you can also check on stuff after. And we can open up a fourth one if we really want. The same sort of things can happen. You can see now everyone is looking at everyone else's machines. I'm just going to kill all these things, shut them down quickly, so I can show you some more demos, if you'd like to see more demos. Yes? All right, cool. So I've showed you the engine, and the engine basically takes this graph of resources, and it runs it. And the engine can actually send different graphs, there's a front end that can send different graphs to the engine as often as they want. So you can actually change basically your running Puppet catalog 10 times a second, or once an hour, or as often as you like. And the way we send new graphs to Mgmt is we have a language which we're building. Kind of like the Puppet DSL, but it has some interesting properties. This is basically the quote of what I was trying to get at when we designed the language. I don't know this person, but they're some sort of computer scientist of sorts. So I really want to have a language which makes it very easy to do what you want, but also very difficult to do bad or dangerous things. Right? Because if you are coding in your infrastructure and you make an off by one error, you don't want to blow away a data center. Is that right? Make sense? Some guy raised his eyebrows. He's like, yes, I do not want to blow away a data center. So I'm going to show you the language, but I just want to show you some of the properties that we wanted in our language. We wanted a language which was safe, powerful, and something you can reason about. In our case, we have a declarative language, so it's immutable, I think is how the common computer science people talk about things. And it's going to be probably a functional language with strong types. The language and the engine is actually implemented in a memory-safe language, so it's all written in Golang. So you won't have random C overflow bugs, hopefully. And it's reactive, which I'm going to show you in a second. And there's a few other properties which I'm not talking about too much today. So here's a demo. Can you see this? Is it big enough? I'm going to actually run this demo. Take a look at the code. I'm just going to get this running. So I'm going to run Mgmt on the left. And I'm just going to, we've asked Mgmt to Just need to fix one small thing. Okay. So we've asked Mgmt to run this code, and that code is going to put some stuff out into a file. So I just want to show you the code first. So up at the top, we have some date-time function, which is going to add this variable a year and put it in y1. And that's weird because a year seems to be defined below underneath here, which is just the multiple of a bunch of integers. So that's actually the number of seconds in a year. Following so far? Here is just actually, the syntax might change in the language, by the way, but this is a big map which takes a bunch of variables. Over here we have some other load function, which is getting stored in a variable, and this vu variable, which also runs some function. And then we have this big string which we print out, and we store it as the contents of this file. Now that might seem a little weird, but here's what's actually happening. Let me show you what's actually happening. If you look here, Mgmt is running, I'll hide it in the background. This is actually what the contents of this file are. And you can notice a few things. I'm pulling the file just so you can see what's happening in real time to this file, but you can see you have the number of seconds, which is ticking along. You have the current load average on my machine, which is changing about every 5 seconds, and you have this other thing. And here's what's actually happening. In our language, it's a reactive language. So all those functions actually return a sequence of variables. And every time the net graph that comes out of all these different variables and functions changes, we push it to the engine. And the thing we're pushing to the engine in this case is a single graph with a file resource that has some contents, which we change very often. And that's kind of cool because we can actually think about variables over time and do clever things. This is just illustrative. And so load average, we can make decisions and change our infrastructure based on a changing load average or some monitoring metric. And just for fun, I actually made a custom function, a VU meter. You know those like things that go up when you hear the music? So this VU meter is actually running on my microphone right now. And if we're quiet, listen, drops down. But if we make some noise, you can see it goes up. So I think, do you like that? Is that cool? So, wait. I'm really flattered that you're clapping, but we're going to make this more fun. I'm going to be quiet, and when I point at the thing, we're going to see if you guys can clap loud enough to make it go up. Is that cool? Are you ready? Okay. Good job. So that's just a sort of a fun example just to show you what's possible. What could you do with this? I mean, this is kind of just a silly example, but think about it this way. Maybe in your infrastructure, you have some office where you have lots of fights. So you could have a VU meter in your office, and if it's really loud for more than a minute, automatically set all the repos to read only because someone's having a fight. You could do sort of silly things because infrastructures are not static. They change over time. And whatever inputs you want, that's up to you. Here's just one silly example. Do you like that? Cool. You want to see more demos, or are you fed up? I guess I'll go. You want more? Come on, you were allowed before. All right, good, good. All right, so I showed you that. I'm just going to kill this. And you'll notice this is very efficient, right? This is not like hosing my whole CPU. If you're in front, you can see that my laptop is pretty garbage. So it's very, very efficient software. I mean, it doesn't waste lots of resources doing these things. Obviously, sending the new number of seconds to a text file every second is kind of silly. You probably wouldn't really need to do this in real life, but there are other things that you could possibly choose to do. So I'm going to show you, oops. Sorry about that. Oh, it's actually, there we go. So I'm going to show you this example here. So here we have, let me just actually run this. Oh. So I'm just running this over here on the left. And we're going to watch. Cool. So what we have here is we have this date-time function. Again, now you know about this function. It just puts out a new number of seconds since 1970 every second. So it's constantly changing since the date and time is changing. We put this in this dt variable. And down here we have these 4 other variables that is like dt and some sort of index operator 0, 1, 2, 3, 4, and so on. And then we're just going to actually cat all of those together into a big string and put it into the file content. So this parameter of this resource. That's a big long thing. And this is what it actually looks like. On the left, Mgmt is running, And on the right, you can actually see the top value is the current date and time in seconds. And I also printed it out as a real time. And you can see the previous values. So now that we have this reactive language, in addition to getting values that changes over time, we can actually look into the history and see what values were. So that means we can make decisions based on if the load is going up over the last 30 seconds, we might want to do something versus something else. Okay, so just a different thing that you can model. And all of this is modeled in a very safe language, so that's kind of key as well. Is that cool? All right, let's build on that. That's just to warm you up to the concept. So what is this? Does anyone know what this is? It's a bad photo. This is actually taken at my parents' house. I just want you to note I'm from Canada. It's in Celsius, the correct units. But the photo was very bad, so I found on the internet a slightly better photo, which is unfortunately in the strange units. What is this? Does anyone know what this actually is? It's a thermostat, right? Remember these old thermostats? This is one. Thermostats have a very interesting property. Does anyone know what that property is, apart from controlling the temperature in your house? That's true, but what's the property? That's not what I'm looking for, though. It's a good answer. It is reactive. That's not the property I'm looking for either. It has another property that's kind of cool. Anyone? Don't be shy. Oh, what did that say louder? Hysteresis. That's right. What is this in German? Does anyone know? It's the same thing. Okay, good. That's what I thought. Of course, I speak fluent German. So, so what is hysteresis? I'll explain to you hysteresis kind of in a silly way. So imagine. Tell him later, I'm going to explain hysteresis. This guy's explaining hysteresis. Like, you know, remember electrical engineering class hysteresis? No. So hysteresis, shh, shh. You're in the fire zone. Be careful. Okay. Hysteresis, imagine we have a super efficient heating in this room. So the heater is very, very efficient. And if it's cold, it'll flip on right away and make the room hot. But imagine it's also super efficient cold outside. And as soon as the room is here in existence, it gets colder from the cold winter outside. So if you had your heater and a thermostat set to, say, 20 degrees Celsius, the heater would flip on till you're at 20, but then it would flip off, and then the room would sort of instantly get cold because it's so cold outside. So then the heater would flip back on instantly, and it would sort of flap back and forth very, very quickly. But in fact, this would break the heaters. And this is actually not what happens if you're in your hotel room or in your house. It actually goes on, and then once it's at that set point, it turns off, and it waits until you're below some other set point, and then it will turn back again. That's hysteresis, and that's just to prevent this flapping. And I want to show you an example of this. Yes? Okay, cool. A little example. So why do you need to know about hysteresis? Oh. So I'm just going to... Hysteresis. Just going to run Mgmt on the left here. And again, this is all running on my crappy laptop. And on the right, this is a little bit testing code. So just, yeah, it's something I'm working on. There's actually a bug in the library. I'm hoping we don't hit it today, but I'm optimistic. So you can see there's no virtual machines running on my laptop. Okay. And you can see 2 have started up. And in addition, I'm just going to run this big watch command, which is going to cat the contents of this text file, and then it's going to run virtualist. So what's actually happening right now is I'm showing you basically the state of some properties on my machine in real time, and Mgmt is running continuously. Now what I've done is I've built a hysteresis system, which is an autoscaler. So if the load on my machine goes above 1.5, it's going to shut down one of the machines, right? So that means there's too many VMs running on this machine. We're going to push that load elsewhere. So we're going to monitor that load and push it elsewhere. However, we want to have some hysteresis. So if that goes up too high, if the load drops too low, we're going to want to actually spin those VMs back up. But not on and off every second, because that would be kind of a waste of resources. So just to fake this, I'm going to actually just make the load go up on my system artificially. Oh. All right, so I'm just going to run a tree command, and we can run yes, and just watch. This is the real system load. I can actually even prove it, okay, by showing you the real load on my system. So it's going up. Let's see what happens when it hits 1.5. Hopefully one of those 2 VMs is going to shut down. Are you ready? Any second now. There we go. 1.6. You can see it shut down. And this is Mgmt declaratively managing the state of that VM. So we've turned off the fake load, and watch what happens when it eventually settles down below 1.5. It's not going to turn on the VM, right? Because we built in this hysteresis. So I set it to make sure that you're below 1.5 for 10 seconds, and then you could actually turn back on. You might pick a longer delay or something. So we dropped below. 5 seconds went by. Almost 10 seconds, 1.5. And boom, and then it started back up. Was that cool? Do you like that? Yeah, you can applause. Thank you. So here's the important thing. So we can actually declare all sorts of complicated resources. We just say, I want some number of VMs, or the state to be so-and-so, or even AWS instances, and it will actually ensure that that is existing in the world. But if you want to set up something like auto-scaling that takes in monitoring data, you don't have to build some complicated thing with 3 different tools and shell scripts. You can take the load average on your machine, or some data from a Singa, or any other thing like that, and glue it all together and build a simple autoscaler in just a few lines of code. And this is possible because we have this reactive language that lets you model these things very safely. Do you like that? Cool. So hopefully, this is all open source and free software and all that cool stuff. So hopefully you like this and you'll get involved. So I'm going to go on a little bit. Do you want to see more demos, or are you fed up? Yes? Are you having fun? Yes. Okay, you got to tell Bern after. So I'm just going to shut this down. I'm going to kill this fash. Just going to. I don't have a lot of RAM, so I'm going to just delete these VMs. All right, so that's hysteresis. So the language actually, I'm going to bore you with a few interesting properties of the language first. So the language actually runs, and then it pushes graphs to the engine. Now, the language hopefully is a very safe language which doesn't crash, and we eliminate runtime errors and things like that. But if it did crash, hopefully it wouldn't be a major problem because it just wouldn't push a graph to the engine. So it should hopefully be even safer than that. So we hopefully will not have any runtime errors, but even if we did, hopefully it won't be something disastrous. It should just die and not like wreck your system. Remember I showed you that earlier example where things were out of order? So because variables are immutable, you can actually have statements and variables and things like that out of order. They don't have to be in the correct order that they run in because it's just a graph of code. Now, if you were to write code in this weird out of order way, you should probably be not a sysadmin. You should not do this. But at least for now, the language allows this, and we'll see in the future if we actually enforce ordering of code or not. But it's just an interesting side property, because if you have a very safe language, you can do these weird things because the compiler is quite smart about that. It just knows what needs to be updated when and figures the rest out. So please don't write out of order code. That would be insane. Variables are actually immutable. So if you did something like x equals 5 and then x equals 6, that would actually be a compile error. So it checks to make sure you don't redeclare variables. And this just prevents subtle programming errors and off by one errors that can happen by accident and things like that, right? In Python, you're like, how come my variable is 7? You have this line you didn't see. So these whole class of bugs can be eliminated, which is important because you want your infrastructure to be safe, right? I think so. I talked to you about hysteresis, which can be used for all sorts of interesting things. I've only thought of a few use cases like auto-scaling and a few other things, but hopefully you and your infrastructures will think of magic things that you can do that will help you much better. Like I said, with the volume meter, if the sound is over a certain level for more than 2 minutes, people must be shouting, so set the repos read-only, or whatever thing you want. So that decision-making stuff is going to be up to you. There's different kinds of hysteresis we can build. This is still very early, so I've only implemented one kind, where we look at the last 10 seconds, but you might look at a sequence of values and do something else instead. So lots of things are possible. And as I've said, these reactive variables in a reactive language lets us build and model all these systems. So we can even, this is not fully implemented yet, but even implement error scenarios. So what to do when you have failures, if things crash, or if inputs to Mgmt could be from one of your monitoring tools that are gathering data from all the clusters. So if you see error rates that go up in a certain thing, one of the actions you can take is to spin up new clusters to handle that higher volume of errors or something like that. So that's really up to you. There's quite a lot of future work to do. How can you help? This is about all of you folks. You can use this, you can test it, patch it, share it, document it, star it, blog it, tweet about it if you have Twitter, discuss it, hack it, and just hack on this stuff, right? This is all free software. The only thing that I'm a little ashamed about is the language stuff, which is still quite brand new, is not in Git master yet. But hopefully by Config Management Camp in February, it will all be in Git master. So there's still lots of stuff to play with, but the language is still kind of brand new. It's hard to build a language, so sorry for that. Another sad thing is, so I work at Red Hat, and they've been actually really nice in that they've been sponsoring my research work on this for excuse me, about 1.5 years or 2 years now. But unfortunately, it's been a little politically difficult because of Ansible. So they've actually completely cut off my funding to work on this. So I'm doing this all entirely in my spare time. So Mgmt needs a home. So if you'd like to work on this or send patches, or you want to help grow Mgmt or fund the project or something like that, please reach out to me, because it's hard building a whole thing from scratch. And I think we're this close to getting it to be something we can really use in production. So that's my cheap plug. Let's just recap what we've talked about today.
Answer. Now let me recap.
This is a bad joke of Arthur Benjamin putting the cap back on his pen. It's a bad joke. So I first want to give you a few links. There's a technical blog of James. You all know about this now, right? Yep. Come on, yes? All right, good. The project page on GitHub, Purple Idea, that's me, /Mgmt, you can find all this code. Actually, Bernd was super awesome and had me at the OSDC conference that NETWAYS had very recently, and that was awesome. So I gave a full talk just about engine features. So all this language stuff wasn't in there, but if you want to see all the different things the engine can do, that video is super well recorded by their team. And there's a whole bunch of articles also on my blog which you can check out. So have a look at that. At the bottom you can see I'm Purple Idea on Freenode IRC, Twitter, GitHub, at gmail.com, at redhat.com. So if you want to bother me, that's how to do it. Here's a dumb slide because I like doing magic-y things. I need your help for 1 second. I'm going to show you an extra demo because I think we have a bit of extra time. We do have a bit more time. But I need you to help me in a DDoS of Bernd. This is Bernd. If you like this talk, I need you to go over to Bernd today. At some point today, just go up to him for like 3 seconds and be like, "Hey Bernd, I really like James' talk." We should do more of that stuff. And if you like, and if all 200 of you or however many of you all go up to him all day, it'll be hilarious, right? So all day, just think about it. DDoS Bernd. Shh. Just don't say it came from me, okay? I don't think he likes this picture, so hopefully he doesn't see the recording. So just to show you, we have an IRC channel on Freenode. We're about 50 or so people, hackers, people just hanging out in Mgmt config. You can hang out. We have a Twitter account and hashtags if you like. And we actually have a mailing list, which is pretty low volume, and I send out announcements about new releases and things like that. So you can subscribe. I won't send you marketing spam. I'm going to take question and answers, and I have one extra demo which I'm going to show you. It depends on the internet. So if there's maybe I'll take one question and then I'll show you the demo. Is that cool? I'm just get the demo ready. So, anyone have any questions? Don't be shy. While I get this demo ready.
So my question would be, you're using the Raft protocol, which can have stale reads if you don't read every read request from the master. So are stale reads of old data dangerous with such a reactive system, or do you read only from the Raft master?
That's a great question. So the stale read question is something that actually I think originally, so we didn't actually implement our own Raft protocol because that would take forever. So we actually build on top of etcd, which has its own Raft protocol, and that code is actually compiled into Golang into our binary. So that's why another reason we use Golang, because it had a great distributed database, which is what we build on, and Raft. I think initially etcd did not have this feature done correctly, but now it actually supports ensuring that your reads are also not stale. And we have not actually, there's a super paranoid mode you can turn on to enforce that this always happens. I believe this is currently not turned on because you usually are okay with the eventually consistent data. But if you find a use case where you think it's absolutely necessary, then we'll either make an option in Mgmt to do that or patch it some way. But I don't think it's going to be a problem. Does that answer your question? It's a really good question, but it's very subtle, and I'm not sure that it will really matter, because you might just, since we're always declaring the state, the worst case scenario would probably be that you declare an earlier state, which is now out of date. So eventually, when you get that new data, it'll get refreshed. So you know what I mean? So you might go from, instead of going from A to B to C, instead of going from A to C, you might go from A to B to C, but you'll eventually get there. So it probably shouldn't be a problem. But again, if you really find something that you hit where it's a problem, we can very easily just turn that flag on. So great question. I'll show this one demo first, and then we'll take more questions. Is that cool? Okay, so don't use the BitTorrent for just the moment, because the internet's kind of crappy. So what I've done over here is I have two windows. These are both on a remote crappy server that I have. I needed a different machine that was bigger than my laptop. And Mgmt is running. This is just a screen session, so you can see both. And what I've done here is I've actually declared the state of this server to run one virtual machine for me. Okay? So if I actually go here, you can see on that machine, we have one VM that's running. Mgmt started up that machine, it booted, and so on. And what I'm going to do now is I'm going to log into the console of that virtual machine on the right. And on the left, you can see that's still that first machine. So it's a machine. It's got a really boring host name. It's one virtual machine with, you can see it's got one QEMU virtual CPU. And just for fun, I'm going to run this watch command, -n 0.5 lscpu, and just grep out that command. So we're actually now running in the VM here a continuous stream of listing how many CPUs are on the VM. And on the left here, we have basically a front end to Mgmt, which can change the parameters that we declare in our code. And just to make this, slightly more theatrical, I've made a little bash script which pushes a new value to Mgmt when I change it. And watch what happens when I press the plus key. So what I'm doing, all I'm doing is the VM resource has a parameter which is number of CPUs. And when I go up or down, it actually just changes that CPU count. And you can see that it changes on the machine in real time, in under a second. So what's actually happening? Every time I press plus, Mgmt, it's reactive. So it says, oh, you said you wanted a VM with one CPU. Now you're asking for a VM with 3 CPUs. So the engine reloads itself. And it quickly says, oh, the VM running has 1 CPU, but you wanted 3. Therefore, I need to hot plug 2 CPUs. So to actually hot plug those things in real time, running there's vert hot plug commands, and you can see that that count goes up. Is that cool? Thank you, thank you. And you can see it's pretty fast. So imagine you had reactive real-time load variables and scale variables that are now actually just even changing the number of CPUs. So now you can auto-scale your clusters and your loads in milliseconds, right? Michael Jackson dies, you notice, quickly auto-scale this, and you're done. So again, just all the different possibilities. There's all sorts of new resources in Mgmt you could run to do this, and you can use all of that monitoring data from external sources and other things to make clever decisions about your infrastructure. So yeah, that's my last demo. So yes, I'm definitely going to go. If there are more questions, I'm happy to take them. Yes?
You can hear me okay? One of the things we like about config management is we can be accountable for our changes. We can define how the state is and keep it in revision control and say, well, this dude made a mistake and messed it up, and here you go. One of the things that seems to worry me about the cool stuff that you've got is that you're blurring the lines between, accountable changes and unaccountable changes. You can have something that reacts and ends up in a state that you might not expect, or you have something that reacts in a way that you like and you want to save that state back into the configuration workflow. Is there a way you can kind of save the state you reached after you figured out where you should be?
It's a really good question. So I think maybe if I simplify it, like, are the states deterministic, and can you ensure that they're repeatable and deterministic? Yeah. Is that close enough? So the truth is, it's not a completely trivial problem, because systems and complex systems are not very trivial. They can get quite complicated. So for all the basic things that we're able to do with sort of Puppet level things now, I think this is basically 100% guaranteed. If you declare a state and you don't do anything fancy, then you will get to that state. And that, probably about the same level of quality minus the speed and stuff you can get with Puppet, you can do with MGMT. But in addition to that, if you do want to do these fancy things, the thing that is dangerous and not repeatable is when you have one tool that calls out to another tool that then runs a bash script that does another thing. Those are the dangerous things. And if you can model all of that in a single language and have that language have extremely safe properties, you're going to get much closer to getting that repeatable design and infrastructure that you want. It does not mean there's no way to blow away your infrastructure. It does not mean that your infrastructure won't have bugs. But I think we're going to get much closer to the most possible solution for these things. It's a really good question. I hope that answers it. And if not, I'll be around today and at the hackathon to hack on this with you guys and girls and answer more questions. Cool? Any other questions? Yeah, in the back. Sorry, Walter. You have to wait.
Just give me a sec.
1 sec. There's a microphone coming. Then everyone will hear you, and I will hear you.
Is there some plans to implement some of this in Ansible from Red Hat sides?
So, that is a great question. There are lots of possibilities that Ansible and MGMT could cooperate. For example, Ansible could ask MGMT to run as a sort of random service to do some of the hard work, and you can keep using Ansible for the broad strokes. All of these things are possible. At the moment, I don't think Red Hat is interested. So it's just a political thing. I'm a hacker. I have completely failed politically at convincing them. I've convinced lots of individual engineers and hopefully lots of hackers in the audience, but I just can't win that game. So if you can win that game, you're more than welcome to try. I will happily accept patches upstream that make sense for the project, and hopefully that's helpful for you. I'm sorry about that. But good question. Thanks. Any other questions, preferably more technical rather than political? Yes, Walter.
So the real-time aspects seem quite interesting. Could you give us an example of how you would see this in a development workflow in an actual like larger environment with multiple people committing stuff?
Dev workflow, that's a great question. What you can do, I didn't demo this today, but I did actually demo this at OSDC, which is recorded quite well, so you can check that out. What you could do for just a single developer, for example, MGMT runs in real time and it's live. So every time you rerun Puppet, for example, you wait a whole lot of time. Whereas MGMT can just apply the delta of what it needs to do. So if you actually, preferably on a dev machine, just edited your code in real time, MGMT can continuously push this so you can actually kind of live hack on your infrastructure and see it update until it's exactly what you want. You probably don't want to do this for production stuff, because that would be super brave, but it is possible. And it definitely made my dev hacking really, really fast. And check out the video, it's super cool. For multiple people, ultimately I think there's really only one way, whether Puppet or MGMT really should do this, which is have all of this config management code in Git, and everyone have push to that repo to make changes and hopefully have some tests run first and so on. There is a deploys feature in MGMT, which is not in Git master yet, but I hopefully will present that in Ghent at Config Management Camp. So good question, bigger answer, but hopefully that will get you thinking more about this. And just to be clear, this is not a solved problem. So if there's ways you think you can make this much better, patches are definitely welcome. Yes, gentleman in the front.
I have some kind of political and technical questions. So sorry for political.
More political questions. Any hacker questions first? Go ahead.
The one thing is we actually migrated all our stuff on Puppet. It's pretty annoying for me, for people who are in charge of this, to get all people into the boat and tell them, hey, yeah, we no want to use Puppet. Yeah. So there comes Red Hat. That tells us, hey, okay, Puppet is nice, but we now have Ansible. Use Ansible. I have to change the whole fucking thing
Okay,
to
okay,
do it
stop,
to
stop.
Ansible.
Okay,
Yeah.
I get your question. So I'll tell you a few things. So it's a good question. As I said, I'm not here representing Red Hat. I'm just here representing my project, which I'm doing in my personal time now. It is a good question. A lot of companies invest in different things, and that's just something that happens over time because things change. I think it would be worse if Red Hat said, we're going to pick Puppet and never change, no matter what happened. So that's unavoidable. As for the Puppet migration, one thing that Mgmt can do, which is super awesome, and I also didn't talk about, but that's in the engine talk, you can actually take existing Puppet code that you've written and compile it and run it on our engine. So all of your old Puppet code can now run way, way faster. There's a few caveats. Not every single resource that exists in Puppet has a mapping that implements that feature. So for example, the file resource in Mgmt currently has no SE Linux parameter. So that would just not work.
No problem, no one uses it.
Well, fair enough. So it is not a perfect mapping, but it is, oh hi, come on in. There's a small child here. That's Walter's child. So that is possible, and you can actually add more mappings for things like that. To migrate, that's probably your best bet, but I am not going to not build something that I think is useful just because there's old tech that still exists. So port the hard things to Mgmt, and then maybe over time you can start porting the other things.
Then the other part of the question, the technical one.
Oh,
isn't there a possibility just to use Mgmt to speed up the development of Puppet modules, for example?
I don't know. If you want to send a patch and discuss how this would work, let me know. So,
okay.
Yeah. Thank you. Any other technical questions? I think we got Julien. We got. I'm going into your break now. So, yeah. Oh, it's okay. Oh, I have 5 minutes more, so that's okay. I'm wrong. So Julien.
Hello, James.
Julien is Mgmt contributor number 2 in terms of patches. So
is the language distributed as well, or do you need to run it on every machine? And what happens to the graph then if you push different values on different machines and you break the distributed way of Mgmt?
So I didn't hear the first word, is the language something, but I understood the rest of your question. What was the verb?
So is the language distributed?
Distributed, yes. Okay, great question. So I did not explain this at all. This is actually not in Git master, but I will be demoing this probably at Config Management Camp because it's not quite ready. But basically, here's how it works. The machine clusters itself together, and then you have this concept of deploys. And what happens is you actually sign the code with your key that ensures it came from a sysadmin. This is done with GPG. And you push it to any machine in the cluster. And the cluster will ensure that everyone has that version of the code, and then that code will run everywhere. And the way you can do this, there's different deploys. So you can either have it run as soon as it gets the code, so each machine, whenever it gets the code, start running it. Or you can synchronize once everyone has the code, then you all run together. So there's different ways to do that, but that's basically how it will work. So yes, the language is definitely distributed across the cluster. Really great question. Cheater, because you use the project and you know how it works, so he's asking harder questions. But that's okay. Gentlemen, here, yeah.
So not that I have an ulterior motive, but if you use management to cross-compile Puppet, are the error messages better than the regular Puppet ones?
That is a good question. That's very good. Are the error messages better? Currently, no. And we actually cheat a little bit doing the cross-compilation. There's a gentleman named Felix who actually wrote this. When I first gave the talk, the first talk at Config Management Camp, I think almost 2 years ago, I suggested, or I pointed out that someone could write a cross-compiler, and this Felix chap thought this was a cool idea and did it. And the way he did it is he actually uses, I think it's called Puppet Faces. So it's this internal thing inside of Puppet that's actually used to partially compile into this weird YAML format. And then we have a second stage which transforms that. And that first stage will basically be Puppet. So if your code doesn't compile with regular Puppet on the master, you're going to get the same error message initially. So, yeah. Make your code compile. I can't help. Yeah. If you wrote Puppet code in the first place, it's your own technical debt, so sorry about that. Any other questions? I'm glad. You guys are a smart audience, so a lot of good questions. Gentleman over here.
Well, I would be interested in if we have a quite complicated, complex configuration, is there some kind of costs on the system, which means load, which is causing by this real-time thing?
Yeah, great question. So I tried to address this a little bit in the presentation, but I'll just repeat a little bit more in detail. So the project itself is written in Golang, and it's a single binary that runs on each machine. The load is extremely, extremely low. So obviously, if you're making hundreds or thousands of changes per millisecond, you're going to have way more load than if you're doing more reasonable things. So it turns out, in my tests, everything has taken much less RAM and much less CPU than the equivalents in Puppet. But if you were really, really crazy and you didn't want to make these changes, I didn't mean crazy in a bad way, but if you're really, really like determined to keep things the way Puppet is, you could have Mgmt run every 30 minutes, shut down when the graph is converged, and then run it in cron again. So if you really want it to run kind of the way Puppet does, you can actually emulate that, and then you'll have basically a guaranteed performance hit, which is always less than Puppet. You can even actually turn off the parallelism so that you have a max of one thing run at a time. So if you have a really slow machine that doesn't do well with like multiple resources running at the same time, that can be limited too. So there's lots of ways, and I think overall you'll be very happy. So is that a good enough answer? Partially. I can elaborate a little bit more on the language. The language itself, the language is actually kind of a graph. So it knows what branches of the language need to be refreshed and don't. So it's actually very efficient in running. It doesn't rerun the whole program over and over again. And you can look into functional reactive programming, and you'll see that these languages are actually very efficient overall. My implementation is not efficient at all. It's garbage, but it's getting better. And even with my like unoptimized implementation, it's super fast. So I was changing a text file every second, you know. So the load on my machine was super low. So yeah, gentleman over here, question. Oh, in the back, sorry.
Yeah. How does this work in a firewall environment?
How would this work in a firewall environment? More specifically?
Basically, if you have some preferred nodes over others, so you, for example, can control who's actually going to be the master.
Yes. So you can definitely decide things like that. I have some fun surprises about this conversation, which I'm going to talk about probably in Ghent if they give me a spot. So it's a great question, but I'm going to hold off answering for now. There's definitely a way to do it, and I'm going to have some special demos planned with this sort of networking and stuff like that for then. So sorry about that. You'll have to wait. Yes?
I would say the last question.
Sure.
If that's okay.
Yep.
Nice talk, by the way.
Thank you. Tell Bernd. Hey, Bernd.
Well, actually...
Bernd is like, what? What's going on?
Actually, I'm going to abuse the time, so I have two questions. First one, are you going to do another magic trick?
Do you want one?
Yeah.
There you go.
So, then the real question, as every agent can talk to each other, how do you do the authentication and authorization?
That is a great question as well. That is a more complex topic, which probably deserves its own talk. So two answers are, one, we have a design partially implemented, it's not finished. And two, I'm not going to talk about it today. It's really a whole other talk, and I can't answer in 1 minute satisfactorily. We have a really cool way of doing this in a distributed way. I think you'll like it, but if you want to get involved, join the project. We'll give you the design, you can help write it, or you can wait and see. So sorry about that. Pardon me? I'm not saying if it's a blockchain. So thank you very much, and happy hacking.
Thank you very much, James.